So what I want to do right now is I want to give you an idea of what discrete math is so that you know what this course is about. And because you may not have really seen discrete math before, I want to make a distinction between the kind of math that you've seen in the past. So for example, you might solve an algebra problem that looks like this. Let's say that 3x, oops, let's try that again. Let's say that 3x minus 5 is equal to 7. Okay, so you challenge us to find x, right? And you know how to do this, of course. You would say x is equal, rather 3x is equal to 12, so x is equal to 4. And we're done. Okay, now let's try some other problems that we might think. Like for example, we might have 2 times sine x is equal to 1/2. Okay, so what do we know? Okay, so sine x is equal to 0.75, and x is some degree. We're not going to worry about the exact angle. Let's just say is the inverse sine of 0.75. But the thing that I want you to realize is that the answers here, x could be any number, right? And in particular, it could be a number like, say, pi. Okay. So, same wise here, x is going to be any number. And in fact, it's very likely to have pi somehow involved in it, right? It might be, you know, 2/3 pi or something crazy. Okay. Now here's the big point that I'm trying to make. X can take a value from an entire continuum. So if you think of the x as being a member of the real number line, so we have 0 and 1 and 2 and -1 and -2 and so on, right? We can actually have x is over here, x is over there, x is this place, and so on. X could be anywhere, okay? In discrete math, this doesn't happen, okay? So in discrete math, what we have is that x can only take on some very distinct values. So for example, x could be 1 or 2 or 3, or any of the other positive integers, right? Or x might be something crazy like red, or a green, or blue, okay? So it's one of those 3 colors. That's what a discrete problem is all about. The answers can only be certain things, okay? So now let's consider some kind of different discrete problems that we're going to look at. We're going to look at things like logic, okay? Now, what's the point here? In the case of logic, I might have a proposition like P, which is going to be true or false, okay? Those are the only 2 values that it can have. All propositions are either true or false. Now, this is the world of mathematics. This is not political science, so we're not going to have something where there's a debate. Okay, you know, is this good policy or bad policy? We don't know. No. We're going to have math. So P might be something like 2 is even. That's true. P might be 9 is even. That's false, okay? There's no ambiguity. So it can only have one of these 2 values, okay? That's one of the reasons that logic is discrete mathematics, okay? Something else that we might want to study is we might, for example, study sets, okay? Now, here's a set. This set is 1, 5, 7, okay? So what we have is that a number like 1 might be a member of this set, okay? And the answer is yes, okay? We can look at another number like 2 and say, is it a number of this set? And the answer is no, right? 2 is not a member of that set because it's not 1, 5, or 7, and so on. Notice again that the answers are either yes or no, and that's it, okay? That's the way sets work. We might look at functions, okay? And here, the functions that we're interested in are not functions like sine, okay? Because those take values from all over the place, right? We actually want functions that have some very small possibilities. So for example, the function might take the number 1 and translate it to 3, okay? So we have here x, and we have here f of x, okay? And we might go from 2, and that's going to go into 7. And we go from 3, and that might get mapped into 5. And 4, and that might get mapped into 9, and so on, right? The big point here is that what we have is a function that is really, it doesn't look like a sine curve or a parabola x squared. So it does have a continuum of values, right? In this case, they have discrete values, 1, 2, 3, 4, and those are the only ones for which we know the answer. So the functions that we'll talk about will always be written like this. They can actually be written as a table that you can look at and consult. What is f of 3? Oh, that's 5. Okay, those are the functions that we'll consider. Those are discrete functions. Okay. Now, what other kinds of things are we going to look at? We'll look, for example, at numbers. Okay, and what we want to study are numbers in a computing system. Okay, so in computers, for example, you have numbers such as 0, 1, 1, 0, 1, 1, and so on. Okay, these are discrete numbers because we're not talking about 1.3. Okay, we're not going to do a lot of these, but computers also have what are known as floating point numbers that can handle fractions. However, floating point numbers always have a finite number of values after the decimal point. More precisely, they can always be written as fractions. So 3.27, okay, is really 3 and 27 hundredths. Okay, that is discrete, right? So yeah, we'll see those, and we'll see how computers represent numbers. That is entirely a discrete problem. Okay, some other things that we're going to look at is we're going to look at some typical data structures that we use in computing, like, for example, trees and graphs. Okay, and a tree actually looks like, it might have a root, and then it has some values underneath and some values, and this one might have this. You have children. That's what a tree looks like, and you can see that it's a discrete math problem. Each node has a discrete number of children. It can have 2 children, 3 children, 5 children, but it can't have 1.5 children. Okay, it certainly can have pi children or e to the pi children. Nothing like that. These are discrete problems. We're going to look at counting. And counting, that sounds like a really easy problem, okay? 1, 2, 3, 4. But actually, counting can be very, very, very subtle. And we might, for example, be interested in something like this. Let's say that we have a board to play tic-tac-toe. And let's say that we also have some dominoes, okay? So I have lots of little dominoes which cover 2 squares, okay? And my question is, how many dominoes can I put in a tic-tac-toe board, okay? I hope that the answer is somewhat obvious. It's exactly 4, okay? That's as many as I can put there. So now let me ask you a more subtle question. How many different ways can I put dominoes in a tic-tac-toe board? And just to give you an idea, this is one possible way. Okay, I'll put 1 domino there, okay? And I'll put 1 domino here. And then I'll put another one there. And another one here, okay? That is one way of doing it. Can you think of others? I'm sure you can, right? And trying to count all of those is not an easy task. That's kind of a discrete math problem. So these are all the problems that we're going to look at. And I like to end by showing you a continuous math problem, right? So here is a discrete problem. I have some kind of a stepwise function that looks like this. And what I want to know is what is the area under the curve. Now, I'm being very careful with this. So I have different kinds of heights. This is 1, this is 2, and this is 3, okay? And these are all at even increments apart. So the way that I can solve this, of course, is I can simply find what's the area here, and this is a 1/3. And then what is the area up to here? This is a 2/2. What's the area up to here? We have a 2 and 1, and the area here, this is a 1/3 again. Okay, so it's close enough. So yeah, I can actually compute this area, and that works. That's a discrete math problem. I'm sure you can see what the continuous math problem that this is similar to, and it is this. It's just a classic calculus problem. What is the area under this curve? Okay, so this is discrete. That's the kind of math that we're going to be talking about in this class. And this is continuous. that is the kind of math that you've probably been doing all your life, and the one that you can pursue in courses like linear algebra and differential equations and calculus and all that type of mathematics.